Welcome to my channel. Today we'll be discussing about some uses of the section formula in the coordinate geometry. Section formula is used to find out many things in the coordinate geometry. Firstly, we'll be discussing about the midpoint formula. Section formula is used to find the midpoint of a given line segment very easily. Here, if we take a line segment A and AB and M is the midpoint of the given line segment, then we can easily find the coordinates of the given midpoint very easily. Here, if we take the coordinates as A, x1, y1, and if we assume the coordinates of B as x2 and y2, then the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. This formula is very easy to remember, since it just is the sum of the x coordinates divided by the 2 and sum of y coordinates divided by 2. For example, if we take a point A as -2 and 1 and B as 5 and 4, here -2 is x1 and 5 is x2. Similarly, 1 is y1 and 4 is y2. So the midpoint becomes the sum of the x coordinates, that is -2 and plus 5 divided by 2 and 1 plus 4 divided by 2, and it comes as 1.5 and 2.5 as its co-coordinate. So this formula is very important for us to find the midpoint. Similarly, another application of section formula is to find the centroid of a given triangle. Centroid is the intersection of the line segment which bisects the given sides of a triangle. Here, if we take a look at it closely, here AE bisects the given side BC of a triangle into two equal halves. Similarly, BF bisects the AC side of a given triangle into two equal halves. Similarly, here CD, this portion CD divides the AB side of a triangle into equal halves. So G is the centroid of the given triangle. We also know that the centroid of a given triangle bisects G bisects the given line into the ratio 2:1. So the formula to find out the centroid of a triangle is the sum of its x coordinates divided by 3. It's similar to the midpoint formula. Here the only thing is one term is just added. So previously we had x1 plus x2, but it's now x1 plus x2 plus x3 divided by 3. So if we compare it with the midpoint formula, there were only two terms, so it was divided by just 2. Here we have 3 terms and it is divided by the 3. So it is very easy to remember if we remember the midpoint formula. It is similar to midpoint formula. The only thing is there is 3 terms divided by the 3. So if we remember this and keep it in our mind, it will be very useful for us to solve the problems regarding centroid of a triangle. Similarly, y coordinate is y1 plus y2 plus y3 divided by 3. Here x1, y1, x2, y2 and x3, y3. These three are the vertices of the triangle. So this is also very easy to find out the centroid of a triangle. Similarly, we can also find the incenter of a triangle. Here, incenter is the of a triangle is the point where all the bisectors of angles of a triangle meet at the point. Here, BE is the bisector of the angle ABC. Similarly, CF is the bisector of the angle ACB, and AD is the bisector. This line is the bisector of the angle BAC. So, incenter is the intersection of the bisectors of the angles of the triangle. So the formula to find out the incenter of a triangle is ax1 plus bx2 plus cx3 divided by a plus b plus c, and ay1 plus by2 plus cy3 divided by a plus b plus c is the y coordinate. This is x and this will be y coordinate for the incenter of a triangle, where this a is the length of the side BC of a given triangle. Similarly, C is the length of the side AB of a given triangle. Accordingly, B is the length of the side of the AC. So here we can summarize as ax1 plus bx2 plus cx3 divided by a plus b plus c, where a, b and c are the sides of the length of the given triangle. So this is also very easy to remember if we compare this with the centroid of a given triangle. Centroid was x1 plus x2 plus x3, but this time we are multiplying with the sides a as x1. So the easy thing to remember this formula is we just take the vertices a x1 opposite the length of this vertex is just opposite a x1, b x2 and c as x3 divided by a plus b plus c. So the way to remember this formula is we just take the opposite vertices and the opposite sides. So vertices and its opposite sides, we just multiply it and we get the sum. Similarly, we can find the excenter of a given triangle. Here, excenter is the intersection of the external angle bisectors of a triangle. External angle is this one. Here, this is the external angle and the bisectors is the point AE. AE bisects the external angle of a given triangle. Similarly, EC also bisects the external angle of the given triangle. And if we produce these bisectors outside the triangle, they will meet at the point which is called the x-center of a given triangle. So x-center is also the center of the x-circle. X-circle is this one. X-circle of a given triangle. So the formula to remember is EC equals to AX1 plus BX2 minus CX3 divided by A plus B minus C, and AY1 plus BY2 minus CY3 divided by A plus B minus C. If we remember the in-center formula, the only thing is the difference in the third expression. Here, in the last formula of in-center, we had taken it the sum, but this time the third expression we are subtracting it. This is how we find the x-center of the given triangle. Here a x1 y1, and the A is the length of the opposite side of the given A vertices. Similarly, B is this one, opposite to the vertex B, and C, small c, is the vertices, the length of the side opposite to the C vertices. So these are the formulas we have to remember and apply it when it is necessary. All these formulas are just derived from the section formulas. So today we'll be discussing about only this much, and in our next video we will be upcoming with the very new and interesting math videos. Thanks for watching.